my talk today is on kind of the law of kelp aquaculture and some work I've been doing trying to facilitate the law's differentiation of different types of aquaculture and including some of the environmental benefits that kelp and shellfish aquaculture might be able to provide. So, just to start, it was a really basic. There are three types of marine aquaculture. Up until recently, the law has not differentiated between the three of them. And that's important because finfish aquaculture is what most people imagine, at least what most legislators and regulators imagine when they're talking about aquaculture. And so until very recently, most of the law about aquaculture was geared toward dealing with finfish aquaculture and in particular with Atlantic salmon aquaculture. There's also shellfish aquaculture, happens to be a major industry for the United States that can have some real environmental benefits. And so there are states like Oregon, Washington, and Maine that realize that shellfish aquaculture is a little bit different than finfish aquaculture and have made some legal adjustments accordingly. But newest to the scene is seaweed or kelp aquaculture. It's only just arrived on the legal radar. And so having to deal with some legacies that may make it more complicated than it needs to be regulatorily. So just some basics. Why is US law growing more interested in marine aquaculture generally and kelp aquaculture specifically? Just some basic world statistics from the UN Food and Agriculture Organization. As the US population, or sorry, as the world population grows, shellfish and seafood and kelp consumption is growing faster. So the basic per capita apparent consumption of things coming out of the ocean has been growing considerably over the last few decades. But if you're thinking about fisheries, wild-caught fisheries plateaued quite a few decades ago, and that is despite increased effort at trying to find the fish, better technology for doing so, but not a whole lot more fish to be caught. And as you can see from this graphic, aquaculture, both inland, freshwater aquaculture, and in the ocean have been filling the gap in demand. There's some reasons why fish are weird. I love this ad from the World Wildlife Federation. Fish are not considered animals in the normal sense. Under any law out there governing endangered species, bluefin tuna would qualify, and yet no one will list them because they are considered food. So not only have we pretty much plateaued wild-caught fisheries, we're not willing to extend the normal protections to species that are in trouble that we would extend to land-based species in trouble. So like I said, aquaculture has been filling that gap. And here again is the FAO's world chart of what aquaculture has been growing. The top gold or yellow, depending on what color screen you're seeing, is aquatic algae. So that has been growing considerably in the last couple decades. The red is finfish grown offshore. The light blue is finfish grown inland. And the kind of teal in the middle is aquaculture of mollusks, almost all of which is marine. And then finally, the purple is crustaceans, lobster, crabs, again, in the marine environment. So growing, but seaweed aquaculture is definitely growing fastest around the world. Now, a lot of that is China. so far. And as you'll see from this chart, under the Food and Agriculture Organization statistics, China gets its own box because it single-handedly does so much aquaculture so far, but that is changing and more nations are becoming interested in all sorts of marine aquaculture, including kelp. So, some other reasons to think about this from an environmental perspective, especially if you're thinking in terms of climate change, freshwater systems where a lot of the finfish aquaculture has been occurring face higher climate hazards than saltwater systems do. So, in terms of being climate change resilient, marine aquaculture has some advantages. Marine aquaculture also has some advantage over capture fisheries in terms of resilience to climate change, because those capture fisheries face higher climate risk than mariculture does in terms of, say, fuel dependence, need to travel farther, shifting target species, etc. So again, seaweed aquaculture is one of several marine aquacultures that are in some ways more climate resilient. All right, so that's just some background on why US law is getting more interested in aquaculture, including kelp aquaculture. Some basic legal background. I call this slide "Why Lawyers Are Necessary Along the Coast." It's complicated. Who has jurisdiction where can vary from state to state. But the line I want you to focus on for purposes of aquaculture is this one. Under the 1953 Federal Submerged Lands Act, Congress gave states the first 3 miles of ocean to mostly control. There's some areas where federal interests preempt, like national security, the Navy, things like that. But for the most part, the states control the first 3 miles of the ocean, which, at least for the moment, is where most of the aquaculture in the United States occurs. So you're talking about states being the primary regulators. So this is one of the projects I am still working on at the moment, just figuring out what exactly states do with their aquaculture. So this is a survey of coastal states and kind of trying to get at how they think about aquaculture in general. Interestingly, only 7 coastal states and American Samoa actually view aquaculture as a marine activity or put it under the jurisdiction of their primary marine agencies for those states. Much more commonly, aquaculture is viewed as an environmental problem, environmental issue, and goes under the Environmental Natural Resource or Conservation Agency of the state. Now, for some of those states, I will acknowledge that is also the state that does their Coastal Zone Management Act. And so these agencies can have considerable marine expertise. But again, the angle at which they tend to come at marine aquaculture is from an environmental perspective, not a food production perspective, say. And then there are some states that lodge marine aquaculture with their state agriculture agency. Some of these are states that have considerable freshwater aquaculture and just a little bit of coastal aquaculture. So that classification makes some sense. But these states tend to come at aquaculture as a crop. And there are some assumptions that go with that as well. So a lot going on in the states, and the bottom line of this slide is no state regulates aquaculture quite the same way as any other state, nor do they necessarily engage in the same kinds of aquaculture, freshwater marine, for instance, or even the types of marine aquaculture that they're interested in. But as I mentioned at the beginning, where law and policy tends to focus is on what I call sort of the quintessential aquaculture, at least in regulators' minds, which is net pen finfish aquaculture, and more specifically, salmon aquaculture. So this is salmon net pens off the coast of Maine. And there are some good environmental reasons to focus on finfish aquaculture and salmon aquaculture in particular. There are a lot of things that are thrown into net pens, drugs, food, etc. They attract other species. There is a lot of waste produced in these net pens that can damage the floor parts of the ocean. So like I said, if that is your image of aquaculture, marine aquaculture, there are some reasons to get into regulation. Now, there's also federal involvement in aquaculture. Anytime you're in the ocean, you're in a presumptively federal space, even though Congress did give the first 3 miles to the states. And so anything more than 3 miles from shore is federal, period. End of discussion. And the federal government has gotten in the business of promoting aquaculture farther offshore in federal waters. A lot of this can be traced to President Trump's 2020 seafood executive order, which he promulgated on May 7th of 2020, and has not been repealed the last I checked, which was very recently. And so this is actually promoting aquaculture in federal waters through what are known as aquaculture opportunity areas. NOAA got the authority under that executive order to set aquaculture opportunity areas, and it looks like the first 2 are going to be off the coast of Southern California and in the Gulf of Mexico, so promoting aquaculture in federal waters. Another agency that's involved in aquaculture off the coast is the U.S. Environmental Protection Agency. It's one of the 2 agencies that implements the Coastal Zone Management Act and approves state coastal zone management plans, which may in turn affect aquaculture. But it also implements the Clean Water Act, or the bulk of the Clean Water Act. And any aquaculture facility that's big enough to have humans out there is going to have discharges into the water. And so we'll be dealing with the EPA for those discharges. But the EPA also has the authority to set special regulations for marine aquaculture and has done so through special permit requirements for concentrated aquatic animal production facilities, which is a complicated legalese for net pen fish farms. So there are some special regulations that go in through those. NOAA, as I've mentioned, is already involved through the executive order. It, with the EPA, also implements the Coastal Zone Management Act. It was put in charge in the seafood executive order of shepherding any aquaculture projects in federal waters that require 2 or more permits and an environmental impact statement under the National Environmental Policy Act, which pretty much any large aquaculture facility will need. And it also implements the Magnuson-Stevens Act, which is the Fisheries Management Act at the federal level. Quite a bit of debate going on right now as to whether the Magnuson-Stevens Act has anything to say about aquaculture whatsoever. The New England Fisheries Management Council, way back in 1999, adopted an aquaculture policy under the Fishery Management Act on the theory that aquaculture was a form of fisheries. But when the Gulf of Mexico Fishery Management Council tried the same thing in the Gulf of Mexico, the Fifth Circuit Court of Appeals, U.S. Court of Appeals for the Fifth Circuit, shot it down in 2020 and said, no, aquaculture is not a fishery. So like I said, a little bit of a split on whether the fisheries management authorities are of any relevance to aquaculture. The U.S. Coast Guard also gets involved. U.S. Coast Guard interested in promoting safety at sea and ensuring safe navigation. So if you're going to build an aquaculture facility in the ocean, you're going to have to apply to the Coast Guard for a private aid to navigation permit, which just means if you've got poles, nets, lines sitting out there where boats might run into them, you're going to have markers, buoys, lights, depending on where exactly it is and what kind of facility it is, to ensure or to minimize the possibility that boats run into it. But the big player I really want to focus on is the U.S. Army Corps of Engineers, which has authority under 2 statutes. It's the other permitting agency for the Clean Water Act. Anytime you discharge dredged or filled material into the water, you're talking to the Army Corps. But more importantly, for aquaculture, it implements the 1899 1899 Rivers and Harbors Act, and Section 10 says anytime you put a structure into a navigable water, which is the entirety of the ocean, you're going to have to talk to the Army Corps of Engineers. So why is all that relevant? Because the Army Corps has some relatively new general permits for aquaculture, and this is the first time in federal law that there is a recognition that there are different types of aquaculture, that finfish, seaweed, and shellfish aquaculture are not necessarily the same. So it follows on from that seafood executive order. Part of the order instructed the Army Corps to come up with general permits for aquaculture. So all of these nationwide permits, as they're called, very easy to get. You have to give pre-construction notice to the relevant office of the U.S. Army Corps of Engineers. They have 45 days to review the project and object. If they don't, the project is deemed approved. Now, importantly, because I sit in California, most of us do, California didn't certify these pursuant to the Clean Water Act. So you still have to go through individual state certification in California. Nationwide Permit 48 governs commercial shellfish mariculture activities. So you can put in shellfish aquaculture. It also recognizes the contribution that shellfish make to improving water quality. And if you're going to disturb aquatic vegetation, you're limited to ½ an acre, but otherwise it's a pretty expansive permit that went through without a whole lot of protests from commenters to make shellfish aquaculture anywhere offshore a little bit easier, at least as far as the Army Corps is concerned. Nationwide Permit 55 governs seaweed, kelp aquaculture, and authorizes the same sort of structures. You cannot raise nuisance species, but it is not limited to native species of kelp. So again, makes it a little bit easier to engage in seaweed aquaculture. And then Nationwide Permit 56, which got the most comment and the most protest, is the finfish. The Army Corps indicated that it didn't think it would be granting a whole bunch of these general permits, that most finfish operations would need individual permits and would be rejected at the general permit stage, but nevertheless, it's out there. So like I said, why these are important: first time federal law has acknowledged there are different kinds of aquaculture with different kinds of environmental impacts, and in particular, that shellfish aquaculture, most specifically, but also seaweed aquaculture, could be environmentally beneficial. These went into effect in March of 2021. Challenges were expected, but they didn't come. So they're in effect. All right, so all of that leads to another area of interest of mine, which is aquaculture, marine aquaculture, and environmental trading, which the experiments are starting. So some aquaculture, including kelp aquaculture, can help improve water quality and possibly help to mitigate climate change. So kelp does sequester carbon. Whether it does so reliably enough to be in a trading program is something that scientists are still working out, but regulators are watching that possibility. If you mix kelp, certain species of kelp into cow feed, cattle feed, it actually reduces their methane emissions, which is a climate change bonus. Bivalves remove nutrient pollution. That's the water quality improvements that the Army Corps recognized. And it turns out if you grow kelp and bivalves together, the kelp can help buffer ocean acidification, keep the pH a little lower, and that helps bivalves grow that are being aquacultured in the same vicinity. So there's some real environmental advantages to these two forms of aquaculture, and the law is starting to recognize that. Now, more progress on the shellfish front, so I will start there. Recognized, like I said, that shellfish do filter out nutrients. They improve water quality. NOAA estimated that restoring oysters to 40% of the riverbed in the Potomac River would eliminate nutrient pollution in that river and help improve the water quality of the Chesapeake Bay. A lot of the Chesapeake Bay states are actively promoting oyster aquaculture to help clean up the bay. Research from 2020 indicates that oyster aquaculture removes about 38.1 kilograms of nitrogen pollution per acre of oysters per year. Oysters are way better at this than clams, but even clams help out with the problem. So when it comes to kelp, like I said, the cutting edge is experimenting with kelp sequestration of carbon dioxide. Like all organisms that photosynthesize, they do take in carbon dioxide. Like I said, the issue is whether they sequester enough of it securely enough that it could be used in a carbon trading program. But it's been calculated that they sequester quite a bit of carbon dioxide. So growing kelp is a potential help for climate change issues. The kelp aquaculture also removes nutrient pollution, not quite as effectively as oysters, but it does take it out as well. And as I noted in the first slide from the FAO, seaweed aquaculture has huge annual production, 27 million tons per year, and is growing at a rate of about 8% per year. So this is a potential new frontier, both on the science side and on the regulatory side. This is a very busy graph from an article in Nature in 2021, but basically showing some of the benefits of aquaculture. The beige band in each graph is what chicken production would accomplish. So it's basically comparing seafood and marine aquaculture to chicken. Chicken is arguably the least environmental damaging of the meat production on land. Beef is definitely going to be worse. So kind of a good comparison. But what I want to highlight is the bivalves and seaweed aquaculture there along the bottom. Very small, perhaps negative carbon footprint. Very good at sequestering nitrogen and phosphorus, and of course, not consumptive of water or land space. So compares very favorably to other sources of food. All right, so where does this come in legally? There is already water quality trading under the Federal Clean Water Act. The EPA, as a policy matter, gave states the authority to set up water quality trading programs if they so desired for nutrients and sediment. You can't do it for toxic pollutants. And the idea was to get to agricultural pollution, which is largely exempt from the Clean Water Act, by allowing point sources, factories, sewage treatment plants who have to get permitted and need to reduce their nutrient pollution to pay farms to put in nutrient pollution controls. And the farmers get money, the nitrogen and phosphorus and sediments go down, and the point sources that have to have permits get a little bit ease in what they have to accomplish. Several states have adopted trading to some greater or lesser extents. It's still fair to say it's in an experimental phase. But the newest experiment is, instead of working with the farms upstream, coastal states are thinking about aquaculture in the estuary. So if you have oyster aquaculture in the estuary, if you have kelp aquaculture in the estuary, can they engage in nutrient trading with upstream sources? And Maryland has said yes, they can. So Maryland is on the cutting edge of this particular endeavor with oyster aquaculture. Said, hey, yes, certified oyster aquaculture facilities can participate in nutrient trading. Maryland has a very robust trading program, a great website if you ever want to explore it, on how to set up water quality trading easily. But in May of 2020, the first trade with an oyster aquaculture facility occurred. A restaurant bought for $1,600 4 pounds of nitrogen removal by oysters. So the question that is now starting to come up is, could the same occur for kelp aquaculture? Knowing that kelp does remove nutrients, although at a lesser rate, could kelp farms also participate in nutrient trading and maybe help remove some of the toxics as well? All right, the other thing to think about is carbon credits. So this is a picture of California's compliance offset protocols. Basically, California has a robust carbon offset program to get carbon dioxide emissions down. Any industry that wants to propose a new protocol, is what they're called, but things you have to do to get certified to provide carbon offsets, can go through the process of getting that approved by the California Air Resources Control Board. And as you can see, livestock projects are already in there. Forest projects are in there. Rice cultivation is in there. There is no legal reason, but for needing a little bit more robust science on carbon sequestration from kelp, that kelp could not get approved for one of these protocols and start participating in the trading programs. So a lot of interesting stuff going on in the law right now. I thank you for your attention. If you want to read more of this, a lot of this came from an article in the Yale Journal of Regulation that came out this year, and I'm happy to take questions.